Now that can be changed, right? We chose that as a number that was representative of a real market fee. Okay,
any other questions? Anyone here? Okay. All right, let's go behind to. So this witness was a final talk, right? Representing the large, he is the principal engineer at Yahoo. He's worked at the Yahoo platform, and he helps various products with Yahoo to use for discussion. One of the problems he's trying to solve here is to really find out the right amount of resources for a given project, especially demand use needs. And he's all going to share with you the science and math behind one of the tools that he has built, by which he's solved this problem. Please welcome Viraj.
Thanks everyone for being at my talk. My talk will basically focus on how do you compute, how do you calculate the capacity for a map reduction job, right? And also how do we go about doing that for an extremely large complex data, right? It can be loosey, fixed, things like that. So why do we need this tool, first of all, right? At a place like Yahoo. Capacity planning in Yahoo, especially, is a very big challenge right now. Considering the amount of projects that we have onboarded in the last 4 years, have been over here, is extremely large. Right? One more problem that we face is project owners need to estimate a sort of a capacity estimation before actually doing something on the grid, right? They need to have a particular sort of, okay, I need this many amount of resources to actually execute a part of my job, let me 50% of my data sets. Because without that, it's a catch-22 situation. You don't know how much you need, you just can't get onto the grid, right? So it's just that you need to have some estimate so that you can run some applications through it, right? So that's the biggest thing that is facing all people who are onboarding on the grid in Yahoo, right? One more thing is, we also have something known as a car review or something known as capacity or CapEx review, wherein every project goes ahead and submits that you need this many resources, is it okay, right? And in an approximate way. And then based on that, they get funding for that, and they can go on to a grid where the HDFS space, the queue, everything else is configured, right? So what this drives is essentially this whole process of doing this onboarding. What we wanted to do was we wanted to make it a self-serve, right? Previously what was happening is teams used to walk to us, how do we consult, how do we make this project, how much space do we need, how much resources do we need to get allocated on the queue, how many map containers, how many Redis containers. And a few years back we were using Hadoop 1.x. We had certain grids that we built in Yahoo, which had a different map reduce slot configuration, maps and reduces are 2:1, and then based on another set of grids where the map to reduce ratio was different, right? And then what happened was some projects were running on X grid, which had a different hardware configuration. They wanted to go on to another grid, which had a totally different hardware configuration. Now, how do we tell them, instead of this much, you may need much lesser in the new environment, right? There's a speed up also associated with that. Network characteristics could change. Right? So all these add to this sort of problem of capacity planning. This is an unsolved problem as of now, and it is going to be still, because there are other challenges also involved. But what I attempted to do, and our team here in grid onboarding wanted to do, was basically simplify this, try to make this a self-serve model so that you have some applications that you run using some sandbox environment. You have some job application logs. Using those logs, you feed it to this tool, which will understand how the job progressed, what was the way in which the mappers and reducers executed, come up with a model, and then tell you need this much to execute it in this much amount of time, right? And accordingly. So the other challenge, as I talked to you about, application developers typically develop their applications in a different environment, right, than they actually run on in production, right? They are shared, they have different prototyping, they run on partial data sets, right, not a full data set. I run only 10% of the data set. Only when I go to the production grid can I be able to run on the entire data set that is generating for the project, right? And we're telling you that. As I told you, research and production grids have varying computation needs and communication costs. And what we wanted to do was, for this entire onboarding process, we have a front-end portal known as support shop, which we call internally, where the users can go and submit their requests. And once they submit the request, this tool known as Imico Inside Support Shop is a web-based tool which tracks your request all the way, starting from the phase where they tell that we want this request on the grid, all the way to its provision, when the actual queues and the actual project space is provisioned, right? So the entire workflow is done using this Imico, right? Which one of my colleagues knows where I work from. And it also interfaces with other systems in Yahoo, right, to get this estimate, right? So in this onboarding process, there is a particular form that people arrive here at, which will basically determine the dollar amount, right? It will be something known as the computing capacity, and also there's also another thing known as the HDFS space. But this one will tell how many map containers I need, what's my memory requirement approximately, reduced containers, right? And how much do you think this entire workflow will take to complete, approximately when we run it, right? And based on this, they need to fill in these numbers. And this is the hardest part whenever you go for any review, right, for onboarding a project, because these are not available, right? Just looking at one single map reduced job, you may get some numbers, but this is not fixed for an entire work. Okay? So what we wanted to do is we wanted to develop a web-based tool on C3. We first of all wanted to have it to be self-serve, right? Self-serve means you submit a request and it will do that analysis for you and send out an email, right? And you don't have to worry about it. We don't want to consult with each and every team. Second thing is, we based C3 on another project that we had developed before known as Hadoop. It's rule-based. So when we use something like a rule-based, it will, what it does is it analyzes the history of the job, how it was executed, and based on that, it will tell you what are the various inefficiencies that your job could have been done based on the rules you have written. Maybe the split size was too small, right? Maybe something else was a problem. So if you use it as a rule base, you can get some. So when people onboard the project, you can also get more information that this job that you're running and trying to onboard on production clusters is definitely not efficient, right? You want that also to happen, and that contributes to that. One more problem that we faced with many customers is they know something known as an SLA, that they want this job to run within this X hours. But sometimes they would be willing to go slightly slower with their costs reduced, right? That I am able to tolerate 4 times or 2 times my current SLA. I am okay with that, right? If my cost decreases. So what this tool does is also gives you, for a particular input, what are the various SLAs and what are the various containers or slots required to run that particular job, right, for various SLAs. Second thing, we want higher complexity with map reduce, slot configurations, with various container sizes that you need, with various speed of your hardware. The other most important thing is also we need something for these job supports for different environments, right? Other than map reduce, plain map reduce, we need for a big script. Big scripts are written in a manner that are essentially either run through an OC workflow or either run through another workflow system, right? But most of it currently is run through OC, and which we are working on to make much better currently for OC support. But the idea was we need something to analyze in the form of a tag. So how does the C3 architecture look like? It's pretty straightforward, where you have a form-based input engine, which we collect, the user can submit, right? He submits, he gets a URL back telling that, this is your calculations are running, and he can go back, and asynchronously when it's done, it sends you back. Why is that the case? Once this goes and hits this browser, goes and or a request or an entry for every run stored. Then on the back end, what we do is we basically go ahead and fetch the actual job logs from our grids on this box, right? These job logs are job history as well as the configuration, which tells you how my job was run, right? What are the various parameters that I gave to my job? Maybe I gave it higher memory, maybe I allowed it to have 3 execution slots. Maybe I allowed it to essentially have some different other parameters that are of interest of me for my capacity. So what this does is the CPU logic goes in, fetches the actual job history for the entire DAG. Maybe for a big script has maybe hundreds of jobs. It fetches it, then takes it in the core logic, which is composed of the rule-based engine, which I explained later, and then does the calculations and then returns that back as a sort of an email with all the table. Currently, we're working on the UI, so whatever you see is a basic table that returns back. So you submit a request, it's captured by the backend. The backend then takes each request, understands the nature of how it is, whether it's a big script or a mapping job or a MC workflow. Accordingly, goes ahead, fetches all the dependent jobs on our grid that has run based on the workflow ID, and then comes back with a report that this is how your job fared, this is how much capacity you need for the job, and then later we can use that as a justification later for approval of resources. So what we did in C3 was we calculated compute capacity based on service relativity, based on SN, right? And compute capacity is determined in terms of the map containers and reduced containers for Hadoop 23 and for 1.2, wherein we have map reduced slots to tell us what the slots we should actually need, right? So normally projects run on research clusters or onboard production clusters, and the tool does this matchup based on an algorithm that runs internally to make sure that it matches the ratio of map reduced slots. For UC workflows, what it typically does is it goes in, looks at your definition, your UC workflow definition, goes inside each of the actions. If it's a big action, then automatically calculates that. That's what these UC workflows. And inside that, if it's a big action, it goes in, finds the dependent MapReduce jobs that are launched as inside these big jobs, and then understands the DAG, uses the DAG, and for each job it goes in, calculates how much time it took to execute, and then it does. And then what it does, essentially, if you run in sequence, you don't need to take the max of whatever capacity you do in that sequential stage, right? And if you're running it in parallel, you add up the capacities. We use that simple calculation to make it as simple as possible. Right? Currency statistics, we have onboarded more than 200 projects in Yahoo using this tool as well as Yahoo. Right? We have made sure that a lot of dollars flow under this tool as onboarding tool. Right? And more than 2,300 requests have been submitted. And we have made sure C3 has analyzed big scripts that have more than 200 individual MapReduce jobs running is a DAG. And one thing that was important is when you run this, a user normally does not know how these jobs are behaving and what are these container capacities at each level, right, at each stage. Using this report, you can find out, okay, my big script has these jobs, and it's that this one actually does some join and takes the maximum amount of time, right? So there could be some optimization you could do at his level if he sees that. Right? Normally, it does not see that currently because that's just shown in an STD log. We take that and we break that down. So what C3 does for is actually doing the backend capacity calculation. It uses a rule-based performance engine known as Hadoop idea. Idea in Sanskrit means the person who analyzes, who is skilled and who analyzes, is like a doctor who analyzes what are the various issues in your job and uses some performance, right? We can basically, Idea consists of a rule engine where you can write various rules which is pluggable. So you basically write a rule that's in Java. You need to inherit certain classes and then write in the prescription what is it that you're looking for. So we take that, and what Idea has at its disposal is it has various helper classes to essentially serialize all the job information, understand the task statistics, understand how much, what was the data that was going between the mapper and the user, what was this simplest form of it. This can be improved and we are in the process of making it even more better. So what we do is we understand right now at the core, given an SLA, right, and if you have a MapReduce job that's running, the reducers, if you change, does not necessarily result in speed up right away, right? If you just change. So we keep the reducers a constant number, right? Then what we do is, in the map phase, we basically change the number of mappers based on the SLA, right? And we use the speed up factor. We get a map phase time. The map phase time we calculate based on not the worst performing mapper, but on a median basis of the worst performing mappers, top 10 worst performing mappers. Based on that, we subtract that from the SLA, and once we get that, we then compute the various mappers that we get, the different SLAs that is given. In C3, we also calculate something known as the minimum SLA. What that means is, if you throw infinite hardware at this MapReduce job, you will never ever be able to run that below the tap, because there is some factor, there is a gating factor which has some serial components in it. So you can never be able to run it smaller than that particular SL, right? That's the minimum runtime. We even calculate that too, right? Once we get the MapReduce slot ratio, then what we do is we then match it if it's a research grid. We then try to run the iterative numerical analysis to match it with the production grid. For Hadoop 23, we don't need to do that because it's essentially is containers. We have basically what is done is the slot concept is not there. So we just look at the MapReduce container sizes, add them up, and then see in the target hardware how much containers can be accommodated and accordingly come up with that calculation. We also take our speculative execution, right? If tasks are relaunched, we add that buffer because many times tasks fail, right, based on the grid, right? We add all that and come up with a number, right? So this is how the front end of this engine looks like. You have a MapReduce job, big job, busy job, right? You enter your Hadoop job ID, right? On a grid that you actually ran on, you have a target grid, you have an SLA in hours, you enter submit. So what happens is, if it's a quick guide, it will give you, okay, so this is the overall SLA, given overall SLA is 2 hours. My tool took a few minutes to run and actually affect all the job IDs. It tells you over here that what the various stages are. Stage 1 is 2 jobs running in parallel. Stage 2 is after that when another job runs. Stage 3 when more jobs run, right? And it gives you a map slots and reduces slot capacity on another grid that we have. Similarly, this is the same thing for a MapReduce job for one SLA. It gives you for different SLAs how much time it takes. We also integrated this tool with another performance analysis tool wherein the user can find out how his job performs, right, based on his various SLAs, right? And also we have this particular thing for different fixed spreads, right, wherein we use different SLAs, right? The SLA of 11 minutes, 12 minutes, 8 minutes. We give a user a range all the way from twice his SLA to more than half his SLA, so that he can choose whatever is the best suited for his application needs. So this is the result that we run with 23. That was with 20 when we ran. With 23 we get map containers. This is our reduced containers. The reducers of containers are still the same, but the map containers vary based on the SLA. So similarly, this is for a fixed script that we have these runs for. And with Uzi, what we do is we basically ask currently to give us a snapshot of the STD logs, sys logs, wherein it logs its entire maps, its entire MapReduce flow. But we hope that in future we are able to actually go to the task trackers and actually get those single launcher mapper jobs logs and then come out with the estimation, right? We are working on that. The future enhancements are important that we are working on. First of all, we should also look at the storage requirements. Many times, storage requirements are underestimated, right? They may not be sure of how much they are doing. So we need to capture all that intermediate data that the job is generating as well as the final data, just to make sure that this job is provisioned on the cluster. We also need to display the average RAM and reduce runtime. We also need to do capacity planning. If a user provides from Hudson, if he has a Jenkins job, we need to provision that. So if he has an XML or a set of that, we need to provision we essentially look at that. We are trying to look at that. We want to have more web services based. The biggest challenge that we have right now, and which I'm working, is if an application is running on a percentage, let's say 10% or 5% of the data, how will it perform if you give it like 80% of the data that he finally expects? How much capacity does it need, right? This requires more of statistical background to actually approximately estimate that. And also we need to estimate if there's extreme congestion in the queue, what is the model that we need to follow to do that, right? So one other thing is we have the job analysis. So based on that, if we can predict how the job would behave with congestion, then it would be very good. So I'm working towards that, and hopefully we'll have some improvements. There are some links of Hadoop idea. This tool is not open source, but the back end of that is definitely open source. You can take a look at that and definitely contribute to make it much more, better, to give much accurate estimates. Because all of this in the end ties to the dollar numbers for us. So if you can make that, it will be really good. We also wanted to open source Hadoop idea for 2.0. There's a Jira on that. One of our friends is working on that. So we have a team that I worked with before now for spread to different companies. Ryota, who has designed the Yahoo page. Kendall is also support shop. And Kimshuk helps onboard most of the projects in Yahoo, right? The single man who helps onboard at least 200 of these projects. We have persons who are at Pivotal and eBay who have helped me initially with the design of this tool. Right? So with this, I would like to conclude my talk. Thanks again.
So what are the key differences between this open source tool and AWS's EMR?
Oh, EMR and
what are the key differences?
So this tool, right, what we are talking about is for Yahoo's script, right? That is exactly functionality for our use, right? And we have, this can be adopted to another model too, but right now what it has been designed is for our customers. We are taking an SLA into account and then going back and finding out exactly how many map containers and use containers, and then matching it to what our ops needs to actually secure this hardware. Right? It can be extended.
And how far away from this tool was fully automatic cluster management automation?
I think there is still a long way to be really realistic. This is because see, the thing is, what I showed you is I showed a very small abstract of the entire complex logic that takes place in Yahoo to start from a project to the end. You can actually meet Kimshuk and he'll tell you more details about how. The thing is, sometimes it's not as easy as just that you have a number, right? Many times there is back and forth on these things, right? Many times there are things where you talk to a customer and tell them, okay, you may not need that, but you need something less. So there is the human in the loop is always required in these processes, right? At all times, let it be any place. You need someone to see these results of life. There could be bugs in this too, right? It may not be adopted to the latest models like Storm and other things which we are working on. So, but there is a long way. This is the first step, so I'm happy with that.
There's a question.
Hey. So I'm just trying to understand the relation between SLA and this number of containers, because how can you say anything about SLA just by fixing number of containers? It also depends that how we are executing them on the cluster.
Yeah. So no, what I'm trying to tell, what C3 does is it uses an already running, means an already finished instance of a package job, right? And then what it does is from there it deconstructs and works its way back to find out if I use the same application or reduce context, how much time will it execute or whatever is the SLA time. So it does the reverse part because it already has a job that has been run using that, right? So that is what I do back. Not that you have an entire, someone comes up to me and says, I have the data set of 10 terabytes I want to do mapping. How do I come up with a cluster? No, I have something that I run already on a sandbox or a small cluster of 10 or 5 nodes. Maybe on a local desktop I have this. Now how do I get onto the actual Yahoo infrastructure?
Have you gone back and measured the accuracy of your model?
So yes, absolutely right. That's a very good question. Actually, I want to publish this work in a conference about the right thing I'm doing at the current moment. So the accuracy of this model is essentially based on monitoring whatever we have onboarded on our current rate and making sure they meet the SLA requirements. Right? In case they do not come back, so currently it's hard enough to track when a project is onboarded. We don't do tracking right from onboarding all the way to when it's running till when it's decommissioned. It's really hard to do with the current infrastructure because we have both legacy. We have currently ones that go to this two and some which are really old, which we have no monitoring of. So I wanted to do that. The best way would be to go back. If you can track a project based on a project ID, then you can actually see how it's behaving once it's onboarded or once it's provisioned on the way. We want to do that, but the thing is we need some changes in Hadoop MapReduce to basically, and also make sure our customers who are running that also use this infrastructure to do it, right? And it's a hard job.
Actually, the utility of this tool is more as a prerequisite to know how much capacity they would need to onboard. So focus is on the front, the initial side of it, then trying to see how much they are actually using, because there are other tools and metrics which, which kind of tracks that.
The comment was like, otherwise you can create a very large, system or basically use over capacity so you meet your SLA. That will be the mode of the job. So the question was, how accurate do you think,
So one to answer the question in another way, right? You have seen like two instances wherein they have used our tool to count and estimate, and now they are using the same tool, their provision to do something really drastic, and in those cases they were never able to meet their SLAs, and they basically came back to us and tell, what is this, right? We are not able to meet SLAs, and then we realized once that you gave as an input was totally different from what you are doing. So in that way, we were able to come to know that there seems to be an issue with the provisioning, but we did not essentially monitor. But that's something definitely I need to make sure in the future that I'm able to measure. So, but we are hopeful since you're already 200 projects, it might be definitely going in the right direction.
Time for the last question. Alright, let's give a big round of applause for all of these speakers. I hope you all enjoyed the class tonight, and I look forward to your feedback on the computer page. We hope to see you again next time. Until then, goodbye. Have a good night.
Slide, slideshow.